Hey, what's up YouTube? Ricky here with Ricky's Creations. I'm back to discuss this rechargeable problem you guys are having. Anyhow, here I have a little water bottle with red glitter. And I want you guys to keep this in mind as I'm going through the differences between some of these rechargeable batteries, because I'm gonna get back to this. So right now, as you can see, all the glitter is at the bottom. But if I was to, let's say, connect this rechargeable battery, what's gonna happen is the ions inside of it are just gonna be jumping around from them being charged. Keep that in mind, okay? Here I have a rechargeable battery that I use to put in my lighter buds. And this thing right now, let me see if you guys can see that. Yeah. Right now, without it being charged straight out of a box, this thing has 3.6 volts. Okay. This is a 4,000 MHAs at 12.06 watts per hour. Okay. On a fishing rod, I use 2 of these. Okay. Here I have a 2665 0 at 2,800 MAHs at 3.7, 47.36 watt hours. And you guys can pretty much tell the size from one another. Now this one is brand new and it's not charged, just like this one is. Okay. I also have the Motorola version, but they're little squares, which I use these for like these other custom toys that I make every once in a while. I usually put these. Why? Because they're flatter and they're pretty much about the same voltage as these. So just because this is this big and this is this big doesn't mean they're different. They're pretty much the same. But when you go from this to something like this one is bigger on the MAHs because of the thickness of how big it is. The bigger it is, the more charging capability they can handle versus when they're smaller. Okay. Now, with all that being said, I also got them like this. These things are tiny, but at the same time, check it out. I don't know if you guys can see it, but at the same time, you see where it says 3.7 volts, but look how many MAHs it is. It's only 110. Still the same volts, but not watts per hour compared to these two here. Okay. So now, can we increase the wattage or voltage on these here? Yes, we can. And by doing that, we could actually take another battery and connect it negative, positive, negative, positive, and it'll give us a bigger amperage, which that would multiply our current. So we went from 3.6, and we're fixing to go from 3.6 to 7.2. 7.17. And I hope you guys can see it. Here we go. Let me do it again. We could jump from 3.6 to 7.17 if we connect them the way I have them. Now, I could multiply these as very many times I want. Positive, negative, positive, negative, positive, negative. All you got to do is multiply the 3.6 into how very many batteries you want to run in series. Now, the only gimmick is that, yes, you can connect them like that. The problem is that whatever chip that's going to charge these batteries needs to have that capability of charging that many watts. So, for instance, I have chips like this, where this is what I use to put in the fishing rods, and it could charge 1 or 2 of these 3.6, or if I run them all positives and all negatives, which I could go ahead and do this. Let's just take 5 for example. If I take 5, all positives, all negatives, this little chip is capable of charging all of them. And that's only because it's going to stay within the 3.6 amperage. Now, if I switch it over from 3.6 and like you saw and switch it over to 7.2, then I have to use a bigger chip. And if I want to go from 7.2 to, let's say, Stan was asking me about his and do a 12 volt, then I could pretty much sum them all up and I could do a 12 volt rechargeable battery. And you could do 12 volts with just 3. But even though I can do 12 volts with 3 batteries, it all depends on what's going to be powered. So let's say if I'm going to power a car stereo. Now, depending on how long I'm going to be having it, these batteries are not going to last you no more than an hour or less on 12 volts. So that means I have to do 3 sets of probably 5 of these and connect them positive, negative to equal out my my hours that I need on how long I want to run that radio for. That's all that matters. Now, I know a lot of you guys want to run a rechargeable battery on y'all's ring light, y'all's phone when it's dying in the cold weather. Okay, we're gonna go back to this little doohickey. Okay, let's say that out there in the cold it's like 30 Fahrenheit. Well, just like us, if we go out dressed like we're going to the beach at 30 degrees, we're gonna freeze our butts off and we're not gonna last very long before we get hypothermia. Now, the reason for this, so you guys can have an understanding of what's happening to these charging batteries in the cold, what's happening is the same thing that would happen to this little bottle as I'm shaking it. At the same time it being in the freezer, this water is gonna freeze. Or not, let's say freeze. It's gonna start to freeze slowly but surely, but everything inside of it is gonna start slowing down. So basically, in cold weather with a rechargeable battery, the ion batteries, which are these, the same thing is happening to these guys in cold weather. Now, whether you guys are using them or not, let's say you have them in your bag and it's cold. Well, what's happening to these batteries is the coldness from them, the the liquid that they have in them is actually being not freezing or not being turned into ice, but it's slowing down the charging particles enough to where they don't move as fast whenever you guys need them, whenever you connect it to your light or your phone. And what happens is the slower they go, the faster that you drain them of their charge. Now, you guys up there have a problem with the cold and charging batteries, where us down here in hot weather, we have a problem with them blowing up. So, what I mean by that is this. You see how thin this battery is? This is a good rechargeable 3.7 mini battery, where this one here is bad, and as you can tell, it's inflated. That means that if I connect this to a charger, this thing is gonna probably blow up or explode. It's not gonna do a big bang, but it is gonna pop, and it's also gonna start a fire. That's why on all these batteries, whether they're rechargeable or not, it has that caution to where it says do not throw them in a fire or do not throw them away, dispose of them properly, yada, yada, yada. Y'all get the picture. So how do I test my batteries? How do I know that I'm buying a decent battery pack? Like, for instance, I got one right here where this one says is, let's see if you guys can see it. Focus, there it goes. This one is 6,700 milliamps at 24.12 watts per hour. Input, it's 5 volts, which pretty much all of them are. And max input is 2 amps, which every household phone charger or whatever other charger you guys have they're all the same. Now the output, it's anywhere between 5 volts to 2.4 amps max, still the same. That's one of my packs. And then I have this one, which I bought this one a while back, a long time ago. This one is the same, but the capacity, I don't know if you guys can see it, it's 10,000 milliamps per hour at 37 watt hours. Now this one has never failed me. This one still has 38%, and I've been charging the phone that I'm on like crazy, and it's still not drained. I've been using this battery for the past 4 days, and it's still at 38%. This little thing right here, back in the days, probably, I think, costed me like $35, $40, and it still hasn't failed me. Then I also have this one, which I'm using to charge the phone. But with this one, as you can see, I got this little computer hooked up to it. Well, what this little computer is doing for me, I am checking to see if this battery here is a true, would say what, 6,700 milliamps per hour at 12 watts per hour. So yes, it says that, and I have no way of checking it without this. So here is the amperage that I'm putting into this device. This is what it's converting it to 5 volts to charge the phone. And here is the milliamps per hour that I'm already using from a full charged battery. So if this thing gets to within range of the 6,700, then for what I bought this battery pack is reasonable. But if this number does not get to where it needs to be, then whatever I spend for it is really not worth it. Now the 3 on this computer or on this chip, it just indicates on how many other battery packs I connected to it. And this battery pack, the first battery pack that I tested was, where is it? This one. This is the battery bank that I made for, well, you guys can see whose it's for. Now, this one here has 6 of these guys. So take all that info, multiply this by 6, and you'll get how many hours, milliamp hours, he can use it at 3.7 volts at 47.36 watts per hour. Now, these are all connected positives to positives and negatives to negatives because I am not going for a bigger voltage. I'm going for a longer lasting voltage, meaning I want to make sure that this battery pack here or battery bank lasts more than 6 hours without a charge and in the cold weather. Now, what's the difference between all of these? Well, bam, I'll show you. Here I got my scale. Hopefully you guys can see that. So, zero it. Let's see here. Let me see. There we go. Okay, see, right now it's at 0. If I weigh this little thing right here, it's gonna only tell me that, wait a minute, change it from grams. We're gonna change the units. There we go. If I weigh this here, this battery bank, it's only telling me that it weighs 5.3 ounces. There it is right there, 5.3 ounces, 5.3. It doesn't weigh that much for the power that it is, because 2 of these batteries, just the batteries themselves, weigh 4.2 or 4.0. So pretty much the rest is in the plastic, and the plastic doesn't really weigh that much. Here I have the other one of these, which is the same thing. 2 batteries in the battery pack. This one weighs 5.5 ounces. Same charge, same everything. Now the 10,000 milliamp one weighs 8.9 ounces. Now, this one's pretty heavy for as thin as it is. This one is a lot heavier than this one when I actually grab it. But this one here, by itself weighs 1 pound, 11.4 ounces. This is way heavier, and I mean, it's heavier because I know what's in it. You know, you got 6 of these, 1 of these here, plus, where are they? With 2 extra of these ports, the charging ports, which these things don't weigh that much. But the purpose for this battery is I needed to make it to where it lasts longer with a slower charge, because that thing takes like 6 hours to charge, where these take up to, this one takes 2 hours, this one only takes 30 minutes. And to be honest with you, 30 minutes charge versus 2-hour charge versus 6-hour charge, the only one I trust is this one and the one I made one time. But the purpose for this video is not the capacity of the power bank that you guys have. The problem that you guys have is these batteries in the cold, they tend to slow down. So basically the same thing that would happen, like I said, if I put this in the refrigerator, the glitter is not going to move as fast. And that is what's actually killing the battery. But what kills the lifespan of the battery is once you plug it in and you drain that battery when it's cold, that's when you guys are killing the lifespan of the battery. And what I mean by killing the lifespan, I'm just simply saying that, let's say when it was brand new, it took you guys 2 hours to charge it. And in that time, the more you used it, you started noticing that the battery always got charged within hour and 30 minutes or 1 hour, and then it took faster to discharge and so forth and so forth. That's when you start noticing that the battery is going bad because it's no longer holding the charge in that battery. So the next time you guys think about going out with your battery packs or battery banks out in the cold, the best thing you guys can do is put some hand warmers around the battery packs or in a bag. Put your battery packs or the battery banks in it. Keep them warm. So like that, whenever you guys get ready to use them, you can use them out in the cold. And as the battery is being discharged, it warms up. So the cold won't ever harm it. And you will save the lifespan of that battery. So I hope this little one-on-one tutorial or whatever this is helps you guys out to understand the charging capabilities of y'all's battery banks. And I hope that you guys, to make your lifespan last on your battery packs, y'all keep them warm. Other than that, this is just me signing off. Peace be with all of you guys, and on to the next one.